equals whatever that constant was, y equals 7. So the second part of this equation is going to be the equation y equals 7. If you just have y, that's a horizontal line, and it's got to go through 7. So here's your y-axis. Here's 7 on the y-axis. It's a horizontal line through that point. And again, what we are ultimately looking for is when are those equal to each other? And that would mean where they share the same point. So we'll put a big fat dot right here, big fat dot right here. That's that shared point where they would have the same values. The x coordinates there are our answers. So if I look at this first one, they are hitting each other at a -10. So that's one of our answers. And then they also hit each other over here at a +10. Oh, that kind of looks like that. So we should get +10 and -10. Those are our two solutions. All right. Easy enough so far. All right. Number 3, real quick, do one of these. So go through this, see if we understood what we were doing. The left-hand side, I'll get you started here. The left-hand side, you're going to graph that absolute value equation. And then the right-hand side, you're going to graph the horizontal line y equals 8. And then see what we get for our two answers. All right, hopefully we're getting close here. So I'll get started here and then see if we match up. Hannah, what would be the vertex of that left-hand side equation? Good. We have an x minus a 1, so our x coordinate's a 1. There's no number behind it, so that's 0. So the v should have started at 1, 0. Now our slopes should be what, Hannah? Good. So now this number in front is a 2. So that's a little different than numbers 1 and 2, but certainly we did that yesterday. You would have had those in homework. So now our slope is 2 and -2. So now from this point, you're going to go up 2, right 1, up 2, right 1, up 2, right 1. So it's a little bit more narrow of a V. I messed up there. That's our slope of a +2, so the right-hand side. And then a slope of -2, we would want to go up to left 1, up to left 1. And then we have our V. All right, and again, we're getting that from that coefficient there. When we go to the second one, we've done 2 horizontal lines now, so hopefully that's getting ingrained. This is the equation of a horizontal line through 8. So we go to 8, and we draw in a horizontal line through there. All right, is that what we're all getting? All right, then what, Fabian? Good. So the solution he gave me first was this intersection point. That is the x coordinate of 5 down here. So that's one of our answers. And then it intersects over here. Where'd you say, Fabian? Yeah, this intersects at the x value of a -3. So the -3 is our second solution. All right, easy enough. All right, last one then, and then we'll go to the next page. Do this guy, see what we think. Then we'll see who can think a little bit here. So graph that one, same exact process. Plot the vertex, do the slopes, graph the horizontal line. And then write down what your answers are. Did you do it? Not yet. All right, Myrna. Ready, Myrna? Ready?
Yeah.
All right, what'd you get for the vertex, Myrna?
3, 4.
Good. So 3, 4 is the vertex where the V should start. So I come over here to 3, 4. So that's where the point of the V is, and it again opens upwards. What number is in front of our absolute value bars, Myrna?
1.
Good. So there's nothing written in right here. So that implies that there's a 1. And then because that's a 1, we want slopes of 1 and -1. All right. So from that point, we're going to go up 1, right 1, up 1, right 1, up 1, right 1. And then on the other side, we're going to go up 1, left 1, up 1, left 1. All right. So this should have been our V. Second part, we're going to graph this horizontal line of y equals a -5. So what this means is find the -5 on the y-axis. So that's way down here. And then we're going to draw in a horizontal line here. What do we write for our answers then? What is it? Good. If the intersection points are the solutions, which they have been in the first 3 problems, do we have any intersection points here? No, that means there are no solutions. So when we solve these absolute value equations, the idea of no solutions is certainly a viable answer sometimes. All right, some of these are not going to have a solution because they would never intersect. Okay. Now that we've seen those, we don't necessarily want to have to graph these all the time and look at them, but that's what they look like graphically. So go to the next page and notice how there are no more graphs, but I still give you these absolute value equations. So we now want to solve these. Instead of graphically, we want to solve them algebraically. We want to just kind of go through an equation. The premise of this first, so up above, I do want you to write this above here. Answer this question for me. What is the answer to that question? Meaning, what x value could I plug in there? Take the absolute value of it and get a 5. Whatever you think it is, write it down. So what x value is a solution to that equation? All right. Anybody feeling clever? What should this be? Hannah. Hannah. So if I do the absolute value of 0, 5. Okay. So Hannah says 5. So now let's do that one. If I plug in a 5 right here, is the absolute value of 5 going to give me a 5? Yeah. So I like that one. So that's good. All right, Myrna, you're raising your hand. Do you not like that?
Would it be plus or negative 5?
Okay, well, she says a -5 would work. So let's say I come in here and I replace this with a -5. Is the absolute value of a -5 also 5? Yeah. So notice how there's two answers this way as well. So on the front page, most of these had two answers. First, second, and the third one had two different answers. The fourth one didn't have any. If I give you this most basic of little absolute value equations, we can see that there are two answers to this guy as well, because there are two numbers I could take the absolute value of and make it equal to this 5, +5, -5. All right. With that in mind now, go to number 1. What I am looking for is what number inside, what could I get the inside of this to equal so that when I do the absolute value of it, it'll be a +11. So one way we can do this is just figure out, when does this little x minus 3 expression equal 11? Like, what value is that? Okay. So set that up. Go write x minus 3 equals 11. And then solve this equation. So I'm going to add the 3 over. Those are going to cancel. I'm going to say one of my answers is 14. Let's test it real quick. So if I go into this x right here and I replace this with a 14, what is 14 minus 3? 11. That's the +11, and the absolute value of a +11 does in fact equal the 11. All right. However, like Myrna came up with two answers for that previous one, and on the front page we often got two answers, there is another solution to this. Because what if this was equal to a -11? The absolute value of a -11 is also equal to 11. So what we're also going to do is take this inside part and find out when it would give us a value of a -11. So we're also going to set it equal to a -11. Once we've done that, again, real simple little equation to solve. Thank you. Add that 3 over. Those will cancel. That now gives us a -8. So now let's test that and see why that worked. So now take this x value of a -8. Here's my x. I'm going to replace it with a -8. Well, what's a -8 minus a 3? Good. -11. So that's why if this equals a -11, it would spit out another solution, because isn't that absolute value also going to give you an 11? Yeah. All right. So when we do these, most likely we're getting two answers. We need to figure out what would make the inside equal the positive value of this and what would make the inside equal the negative value of this. And both of those should end up being our answers, most of the time anyway. All right. So now, if you look at number 2, this would be kind of the key to doing these moving forward. If you look back at number 1, notice how those absolute value bars are all by themselves. In number 2, that is not done yet. So the first thing we want to do is to get those absolute value bars all by themselves. So if we're going to do that, I really don't want this -6 over here. I want to move it to the other side. So old algebra, nothing new in that case. How do we get rid of this -6? What would we just do to both sides, Maria? Good. So you're just going to add 6 to both sides. So then that goes away. And then now this absolute value part is all by itself. So that's what we want. And it now equals a 25. Once that is by itself, that's when we set up your two different equations here. So I want to know, when would 2x plus 1 give me the +25? But also, when does 2x plus 1 give me that -25? So we're setting it equal to the +25 and the -25. Subtract 1 from both. Again, the equations, once we get here, are pretty easy. And subtract your 1 over, divide by that 2. One answer would be 12. If we do the same thing on the other side, subtract 1 from both sides, we would get a -26 on the right-hand side. If we divide that by 2, we get a -13. One more time, I'll kind of show it just so we kind of understand this. If I now take this +12, what is 2 times 12? 24, add the 1, that's when I get the +25, so that the absolute value gives me this. And at the same time, if I took the other answer that we said we got, a negative 13, 2 times a negative 13 gives me a negative 26. But when I add 1, doesn't that give me the negative 25? But since we're going to do the absolute value of it, that's why that's still an answer. All right, making sense, hopefully. Okay, then number 3. Don't let an extra step here fool you. You don't necessarily need to write this down, but let's say above this problem, I gave you this equation. When we solve an equation, we're always trying to isolate the x. What would we do for the first step in this problem? The one that I just added. Fabian? You would add 8. Well, if you look at this one, this is identical. This is the exact same thing. Aren't we just trying to isolate this x plus a2? So the first thing we're going to want to do here is just what Fabian told us to do in that previous one. We still want to add 8 right there. So we now have the 3. We still have those absolute value bars. The 8 is now gone, and it now equals 30. Are the absolute value bars isolated yet? No, we now need to get rid of that 3. So think about up here. If I would have added 3 to this one over, or added that 8, I would have had this as my next step. What do we do now to get rid of this 3? Look at this one here. You would divide by 3, right? Because it's a product. It's 3 times x, and we undo multiplication through division. So it's the same here. This is being multiplied. So we would want to divide by 3. Then this cancels. Now we have our x plus 2 all by itself, and that equals 10. All right, see if you're understanding where those 2 equations are coming from now. So set up the 2 equations, solve them. Those 2 should be our 2 answers. 54, 56. Yes, sir. Yep. So I'm afraid of. Oops. Yes. What is it? Good. So Jackson said one of them is 8. Did you set up the equation or you're just kind of doing it in your head? Okay. Okay, so he's doing, so understand how what doing it in our head is actually nice because it really shows we're understanding what's happening. The reason he picked 8 right here, was 8 one of the answers if we set up our equation? Yeah, it should have been. Because he understood if I did 8 plus 2, isn't that a positive 10 whose absolute value is a 10? So one of those answers is 8. But he also understood if I can make this blue part a negative 10, that's my other solution. So the x value that makes this blue part a negative 10 would be a negative 12. Wasn't that the other solution that we got when we set up our 2 equations? So that's what we're doing. When does the inside equal the positive 10? When does the inside equal a negative 10? So that x equals a negative 12 should be our answer. All right. Now, some of them get a little bit more involved. So setting up these equations, we still probably want to do long term as they get harder. But if you just subtract 2 here, that's the 8. Let's subtract 2 here. That's going to give you your negative 12. All right. Is that what we got, hopefully? All right, real quick, go to number 5. Solve number 5. Get this guy by itself. So we're going to skip 4 for a second. Isolate that x minus a 6. All right, so to do that, Catherine, what do we have to do to get this by itself? Good. Subtract the 10 over. So these are going to cancel. I now get that absolute value of x minus 6 equals that negative 9. All right, let's say you set up your 2 equations now. So go ahead and do that real quick. All right, so my guess, we did x minus a 6 equals the negative 9, and then the other one would be x minus 6 equals a positive 9. We would then add 6 to both sides. So we would say one answer is a negative 3. If I add 6 to both sides in the other one, that would give us an x value of 15. All right, is that what we did? Makes sense. All right, let's test these guys now. So let me take this 15 first. So let's take 15. Come on. What is 15 minus 6? 9. And then the absolute value of 9 is 9. Does 9 plus 10 give you a positive 1? No, so that's not an answer. So even though we got it, that doesn't work. Let's take a negative 3 now. So let's try this negative 3, see if he's going to work. So I'm going to take that negative 3 minus a 6. That's a negative 9. But I want the absolute value of that. What's the absolute value of a negative 9? Positive 9, right? And does 9 plus 10 equal a 1? No, that also does not work. That means that this is one of these that has no solution. Think about this graph real quick so you can see what we did on the front page. If I had you graph this, isn't the vertex 6, 10? So I have that right here. And isn't it a V that opens upwards? Isn't this a horizontal line through 1? Would those ever hit each other? No. Now, how do we know that moving forward? This is important right here. So real quick, when I take the absolute value of a number, an absolute value is always going to be what kind of a number? Positive. So could this ever equal a negative 9? No. So if you ever get your absolute value bars isolated, set equal to a negative number, that's how you're going to know that you get a no solution. Okay? Yeah, pass those out. Okay, last homework of the year. At least that I'm going to make do. You might get an extra credit 1 or 2 to help some grades. At the top right-hand corner, it says 2 through 22 evens. That's because that's what you're doing. All right? So you're just going to do 2 through 22. You're just going to do the evens. I probably want to do another one of the 2 of these tomorrow. So we'll do a couple because you should have a no solution or 2 on there. Okay? So I can use yours as the key now then, right, Riley?
Yeah.
Just put yours next to everybody's and know that this is all good.
Yeah, go look at it. It's very neat.
I'm sure it is. You're a very neat person in general. You know? I'm sure it is. I'll take your. Hey, are you ever going to grab your coat?
Yeah.
Okay. I mean, it doesn't bother me. I just want to make sure you remember it's here.